All right. Derivative of e to the x, numero uno. There's not really a second one. The second one's natural log and 2 to the x and crap like that. Okay, so find dy dx for each given function. You know, I'm going to make fun of you a ton, and then on a quiz, I'll mark it incorrect if you use y prime when very specifically asked for dy dx. The derivative of e to a power is e to that power, natural log of e. You don't have to write the natural log of e. That's 1, but you may want to. If there's background noise, I'm actually doing this at my mommy's house, and they're playing with the kids. All right, so e cubed, you might be thinking the derivative of e cubed is e cubed times the derivative of 3 is 0, but hopefully by the end of this assignment, you'll start to realize e cubed is a constant, so we might as well just do the derivative of a constant as 0. 3e to the x, that's a constant, times e to the x, which is going to be that constant times the derivative of e to the x, e to the x. This is going pretty quickly. So you don't need the product rule here. The derivative of a constant, e cubed, times a function is just that constant times the derivative of that function. So this one's pretty quick. Dy dx is e cubed times e to the x. Shoot. I thought maybe there were ones on the left and right, but nope. Top and bottom. Okay. E cubed times e cubed is going to be another function, another constant, and the derivative of a constant is 0. So you have two choices here. How about we do them both? So dy dx as written is the first function times the derivative of the second plus the second function times the derivative of the first. And so dy dx is e to the x plus x is e to the 2x, and there are 2 of them, so we'll double it. We could have also written this as e to the 2x. And in that case, we can just use chain rule, and e to the 2x has a derivative of e to that same power, 2x, which has a rate of change of 2. Good times either way. All right, speaking of, I think when I wrote this, I was trying to get people to see, and maybe I guess if you're not watching this, you might realize on your own that these were the same. The derivative of e to a power is e to that same power. That power is 2x, which has a rate of change of 2. Hey, this looks familiar. We did this in class. The derivative of e to a power is e to that same power. That power is e to the x, which has a rate of change of e to the x. Dy dx is e to the power, e to the x plus x. We're just adding those two exponents since the bases are being multiplied. All right, see if I can trick you here. The derivative of 3 sine is 3 cosine of x, and the derivative of e cubed is 0. All right, let's try it again. The derivative of 3 sine of x is 3 cosine of x, and the derivative of e to the x is e to the x. The derivative of sine of 3 is 0, and the derivative of e to the x is e to the x natural log of e. Maybe a slight challenge. The derivative of 3 sine of x is 3 cosine of x. E to the 3x, that's e to a power, and the derivative of e to a power is e to that same power. That power is 3x. Chain rule times 3. Well, finally something where we have to use the product rule. The derivative of a product of two functions is the first function times the derivative of the second function. The derivative of sine is cosine, plus the second function sine of x times the derivative of the first. And we'll go ahead and rearrange e to the x times cosine of x plus sine of x. Ooh, we're getting down to it. Okay, quotient rule. You know, we could also, I suppose, rewrite this as cosecant of x e to the x. I think I'd rather stick with e to the x and sine of x. So denominator, sine of x, times the derivative of e to the x, minus the numerator, e to the x, times the derivative of sine of x, cosine of x, all over the denominator squared. So we should probably rewrite that. E to the x times sine of x minus cosine of x over sine squared. How many did I assign you? A ton. Still using dy dx though, right? The derivative of e to a power is e to that same power. Let's save some effort and leave room for the chain rule out front. That power is sine of x, which has a rate of change of cosine of x. Ooh, reverse. The derivative of sine of something is cosine of that same something. That something is e to the x, which has a rate of change of e to the x. And the derivative of sine of something is 0 if that something's a constant. Sine of e cubed is a constant, so its derivative is 0. What about e cubed times e cubed? Well, sine of a constant, again, is just a constant, which is going to have a derivative of 0. Oh, cool. Finally, we get to do the derivative of sine of something as cosine of that something. E cubed is a constant, so that's going to be e cubed times e to the x as the input, which has a rate of change of e cubed e to the x. We'll just be consistent and rewrite that out front. All right. Sine of e to the 3x has a derivative of cosine of the same input, e to the 3x, which has a rate of change of e to that power. That power is 3x, chain rule times 3. So dy dx is, I think the best way to write it is 3e to the 3x cosine of e to the 3x. Whew. So this last one, hopefully you're thinking, something about finding the derivative of a constant. Also, I finished that in 8 minutes. It's probably going to take you slightly longer because you had to copy problems, but I don't know, hopefully not more than 15.